There we go. Hey, Andrew, how you doing?
Good. How about yourself?
Not too bad. Was it Friday? Happy Friday to you. Uh, Give me a second here while I get one other thing configured, and we'll be off and running. So thanks for joining me here. We're gonna get started on, I think this is what, episode 5 of On Air, which is pretty exciting. So today we've got some really cool stuff going on. We are going to be basically taking an application, and for us an application is a sensor that generates data at the edge and transmits that over the Helium network and ends up in an application. And we're going to walk through kind of the whole, oops, sorry, let me switch the camera here. We are going to walk through the whole path of this application. So I've got Andrew Thompson here with me, who is, you're based where these days? Nevada, California?
Yeah, I'm in Marin, so just north of San Francisco.
Okay, yeah. And you used to be in near Canada, right? Upstate?
Yes, I used to live in extremely upstate New York.
Cool. So why don't you start by telling people what you focus on at Helium?
I do all kinds of things at Helium. Most recently, I've actually been working on the element. The element that comes with the dev kit is the thing that I've been I spent a lot of time the last 6 months working on. And then slightly more recently, I have been doing some sensor bring up work for Helium to actually add sensors to the new dev board that we've got. So I've been buying lots of things on Adafruit and SparkFun and trying to make them work and
listening to
me data sheets.
Pester you about writing Helium Script so we can deploy documentation. Okay, great. So before we get into this stuff, I just want to make a few announcements. So as usual here, we've got this link behind me. So store.helium.com is where you can go buy all our hardware. We're running a 20% promo on dev kits and I think most other things that you buy. So that code devkit20 at checkout will get you 20% off of an already very, very affordable dev kit, which starts at 99 bucks. Okay, other sites you can check out are dev.helium.com as well if you need any sort of documentation while we're talking about this. So general kind of flow for today, we're going to take two sensors. One is a 9-axis accelerometer, and then another one is an ambient light and proximity sensor, affectionately known as the VICNL 4010 around the office. And we're going to walk you through how we actually make that connection. And Andrew's, here we go, showing these two over there. We're going to walk you through how we actually make the connection from the Helium dev board to the sensors themselves. And we're then going to show the Helium script that connects these things and makes the sensor actually do its job. And then I'm going to, hopefully, if we can get the application windows to cooperate, show this data kind of showing up in real time. So let's start with the 9-axis accelerometer, and I'm just going to switch the camera over to you if you want to just kind of show that and talk about it. So briefly, for people, let's assume people don't know what it is. What can one use one of these for, and why are they useful?
So this is the LSM 9 DS1. It's I think the latest 9-axis that ST Micro makes. It's called a 9-axis because it has basically 3 different sensors inside. Actually, it's 4. It also has a temperature sensor, but 3 different sensors inside of it. It's got an accelerometer that you can think of like a spring. When you are accelerating the device, the spring is going to bend one way or the other, or up or down, or to, it's got 3 axes of each, and it'll be able to detect acceleration. The gyroscope, I believe, works by there's a little mechanical component that's buzzing back and forth very quickly, and it will be actually be able to detect just steady motion. So an accelerometer, when you're not accelerating, you're going at a fixed speed, it won't detect anything. The gyroscope will detect motion even if it's at a fixed steady speed. And then finally, the magnetometer detects magnetic fields, and so you can use it to determine your heading relative to magnetic north, because usually magnetic north is the strongest magnetic field you're likely to see, unless you're putting it right next to some giant magnet, which I have here, or like a big piece of machinery that's generating an electromagnetic field. Usually north is north, and you can use that to figure out what way you're pointing. So these sensors are commonly used in cell phones for things like augmenting your position. figuring out which way you're walking. Like if you ever use Google Maps, it'll kind of show you the direction it thinks you're walking in.
Right.
That's what this is. That's what this is doing. You know, you've ever had to calibrate your phone by swinging it around? That's what you're calibrating. So you're calibrating one of these things.
All right. So can you hold up the full kind of sensor setup? And then do you have the dev board at the end of that too?
I do. This ribbon cable is a little bit excessive. So
I like the ribbon cable. I'm a big fan of it.
Yeah, it's nice. It's just a little. Sometimes they're a little long. This actually has a lot more pins. It can also do SPI, and there's also interrupt pins. I haven't brought up interrupt on this. I literally just finished getting this sort of working yesterday, so we're taking a bit of a gamble here.
So that's the chip on an Adafruit breakout board, right?
SparkFun, this one is.
SparkFun, I'm sorry, SparkFun.
Yep. So that little black thing is in the middle is the only actual. You can see how tiny it is compared to my fingernail. That's actually the only interesting part. The rest of it is just making it big enough and adding some whatever resistance and stuff. So yeah, all the magic happens in that little tiny black chip in the middle.
And then what are the what pins? Those are I2C pins you got there?
Yeah, there's four I2C pins. We got power, ground, clock, and data. And then on the other side, we have some interrupt pins. We have some SPI pins that we aren't using. I haven't hooked up interrupts to this yet. Eventually you'll be able to say if I see an acceleration of more than X G's, throw an interrupt, or if you can set up all kinds of interrupts on this thing. I just haven't fully understood the data sheet yet. So
and on the Helium board side, we're just that's pinning directly in with our ribbon cable, right?
Yeah, just plugged in the standard way.
Okay, nice. So can we take a look at some of the data that the thing's thrown off?
We can. Let me. So I'm actually going to. Oh, did this go off again? It did. Come on. 1 second here.
Yeah.
No problem. I'm not gonna bother with that. Okay. So let me. I need to share my screen right now.
Yeah.
Okay.
All right.
That looks good.
Yeah, that looks good. Maybe make it a touch bigger.
I cannot.
Okay. We already had this discussion.
All right. Yes,
that
so I'm going to actually run the script here.
Okay, so just to back up, so Helium Script is a Helium Script CLI. This is what people use to, at this point, deploy scripts from the command line. We'll have a way to do it from the cloud very soon, but for the moment, that's what you're doing there. And then can you just kill that and start it again so we can walk people through it?
Yeah, it's a little dicey right now. It's not. Okay, there we go. So right now we're just streaming magnetometer values out of this thing, but it's not too easy to visualize this. So I actually have a slight enhancement here that we should actually open source. It's not anything exciting, but let's see how this works for you.
All right. And so what Andrew's doing here is using the script tool to deploy this LSM9DS1. Is that loop? We've got that script up on the script repo, right?
Yeah, no, yeah. This one is like too new right now.
Okay.
This thing
It'll be there soon.
Okay, so now we have. As I move this thing, you can't see me moving it, unfortunately. But as I move this thing, you can see this is the magnetometer. So as I'm tilting it, you can see sort of the magnetic fields moving around.
Right.
And I also happen to have a nice, incredibly strong neodymium magnet that I can wave in the general direction, and you can see it go completely crazy.
And so talk, while you're doing this, talk about the path in the Helium context, how it goes from this sensor that we've wired from this SparkFun breakout board to the Helium dev board and shows up here in your soon-to-be released kind of plotting tool.
Okay, so if we run it just without the pipe, so right now I'm just running this command. So I have a Helium script. I'm relying on the print command. So I'm printing four parameters. Now I'm printing a sequence number. I'm printing the x coordinate, the x value, the y value, and the z value.
Okay. And
my plot script just looks at how many outputs there are, and then the first one is always the sequence number. So you basically plot, number of outputs minus 1 as a line. So I could have, and so and then it just generates a graph and just does a real time. Basically, what it does is it just refreshes the graph as much as you tell it to. If you see when I ran it, I told it to plot the last 50 samples and to refresh the graph every 100th of a second.
Okay.
Yeah. So That's basically all that does. So now we can actually we can look at that script.
Yeah, it'd be great. And actually, if you when you open it up, if you could take a couple seconds to point out what the ports are specifically that you're mapping here.
Ports? Oh, you mean what? You mean down here when I'm?
Oh yeah, that's okay. That's less relevant to what we're talking about. Okay, I got you.
Okay. Yeah. So all I'm doing here is in this while loop, I'm just reading the magnetometer values out and printing them. We can actually change this. We could do the accelerometer, or we could do the gyroscope if we wanted. So like let's do the accelerometer and see if it's going to hit. There we go. The accelerometer is.
Look at that.
That's interesting.
Yeah, that is cool.
But I don't know why it's so jagged. Maybe because anyway. It's not happy with me.
What is the accelerometer data type? That's a.
They're all just 3 integer values. So there's X, Y, and Z for each one, that's the one thing about this. That's why I kind of wrote this script is turning a accelerometer output from one of these sensors into something useful is actually it's hard to visualize just seeing a bunch of numbers. So that's why I kind of brought up the I wanted to do this real-time graphing because otherwise you can't really. Oh, I see what I'm doing. I have two lines uncommented. That's why I'm crazy. I was plotting the gyroscope and then the accelerometer. So now you can see this is the accelerometer. You can actually see gravity. The top one is actually the Y axis. I'm holding it straight up, so you can see gravity is pulling the accelerometer down. Yeah, the others are pretty low. So as I tilt it, these lines are actually gonna move around. So now you can see that the X coordinate is higher because that's more affected by gravity.
Right.
And if I shake it, I get, if I shake it side to side, or if I shake it back and forth, a different line gets and then up and down. I can make the different lines do different things.
Very cool.
And then the final one would be the gyroscope, which we can just do real quickly.
Okay.
For completeness' sake. As you can see, I'm just editing the script and then running it again. Yeah. So the gyroscope is pretty cool. If I just let it alone, actually, I think my computer is making that buzz. But if you can see, if I tap, it's very sensitive. So if I tap, the desk gets on. You get all this kind of stuff. But also, if I shake it a lot, you can see again. But it will actually go to 0 at rest if you let it. But unfortunately, I think there's enough vibration. Me talking and the computer humming and all that stuff.
And you being in earthquake-rich California.
Yeah. Actually, you can, so it's actually also auto-scaling, so it's actually getting very noisy. If you look at the actual axis, it's fairly, but anyway, you can basically see very, very small vibrations with the gyroscope. It's actually incredibly sensitive. When you
That's awesome.
Crank up all the values. You can actually look here's the 3 different components I'm initializing. So I can tell it how often to sample. I can tell it what scale to look at, 2000, whatever. I can tell it what axes to turn on. So I can also say something like, I don't want to turn on the Z-axis for the gyroscope. I just want to turn on the X and Y axis. And there's a lot of tunables in this thing. So I've been trying to wrap it up into something where you don't have to do, like these functions to bring them up are actually fairly. So just wrapping this away and just giving you some nice, API to do it has been what I've been trying to work on here. So
nice. Okay, so switch your screen off for a second. Hold that sensor up one more time. Just one.
Sure. Let me remember how to do that here. Is it going? Okay.
Yeah. All right. So, you've not just been doing this for fun as far as building on top of this 9-axis accelerometer. What can you just say a few words about what we're doing specifically for like clients building on these things?
Yeah. So. So this particular sensor is we have an industrial customer that came to us and said we want to monitor this machine, and this machine has some moving parts, and they want to know what the moving parts are doing. And when I'm obviously being vague here because I don't want to give the game away, but so basically the idea is to slap one of these little 9-axes on there. Because then, if you have a 9-axis, as I said before, you can understand your movement in 3D space, basically relevant to some starting point. So obviously, the machine would be at rest, and then the machine would do its thing, and we would be tracking the movement of the machine over time. And when we saw some condition that we wanted, we'd be able to actually then throw a message up to the cloud and say, all right, we did a thing, or even better, actually count them, count a certain number of them, and then say, we did X operations per minute, and especially because we're trying to do it in a way that doesn't require a particular model of machine. A lot of these machines look the same, and a lot of factories have 5 or 10 different models of the same machine. And if we can do something that's generic like this, that's like, all right, you just instrument the machine and you look at some mechanical telltale or mechanical proxy for it doing its work, then we don't have to worry about interfacing with specific wiring or sort of actually getting invasive on the machine.
Yeah, it opens up a lot of opportunities for us to basically use the data already being created by the machine in a way that's I guess exterior to the guts, right?
Yeah, and also you can do things like with this one. Obviously, you could look for vibration. You could say, all right, I see a normal vibration pattern, and then when it starts to get bigger, you can say, all right, I think maybe you have a bad bearing, or something's good. You're getting more vibration than you were before.
Yeah,
we saw how sensitive that gyroscope is.
Indeed.
So,
okay.
Anyway,
all right. So that's 9-axis. Let's go to the VCNL 4010. Real quick.
Okay. Hook it up here.
And just so people know, we're actually about to publish a full sensor tutorial on actually building what Andrew's about to show you.
So this is a it's got 2 components in here. It's got a infrared LED, and it's got maybe 1 or 2. I'm not sure exactly. It's got a photosensor in it. So what it does is when I turn it on, it's going to start emitting infrared light out this way, and it's going to check the amount of light that bounces back. Mm-hmm. So if I move something close to it, it's going to see more ultraviolet light, or sorry, infrared light coming back. I think it's infrared light. It's like a remote control basically. So the more it sees, it's going to turn that into a proximity value, and we'll be able to do things like throw an interrupt when something is too close to the sensor. This sensor isn't particularly long range. It only has a fairly short effective range.
Sure.
We have another one that we just got in the other day that uses an infrared laser, which will give you up to 2 meters of proximity information, which is really cool. This one is not. That one's actually brand new. It's like literally just come on the market, I think. So but it's pretty cool. So we're working on getting that one brought up as well. But this would be useful for something like, is there a component, or is something here or something not? You'll be able to you can detect that. Right. And it will throw an interrupt. You can basically tell it to sample in the background, and when it sees a certain level of interrupts or a certain distance, it will throw an interrupt and wake up the main microcontroller.
Nice. So, okay, and then show the whole thing so I can see. So dev board talking to
sure. The entire
dev board, ribbon cable. There's 5 ITC pins there. We had the solder.
There's actually 6. We don't use one of them. One of them is for the 5-volt rail we don't use. So that we do have the interrupt line hooked up in this case. The white cable here is the actual interrupt. The interrupt 0. There's 3 interrupts you can push back to the dev board.
Yeah, I mean the interrupt stuff is so cool. You can do so much. Hopefully, as we'll see, you can use a lot of really cool stuff with interrupts if you take the time to write the Helium script to do it.
Yeah, it is a little obnoxious to get the interrupts to work, but okay. So, oops. Angry with me right now. Come on, wake up. Sorry, it doesn't always like it when I change hardware on the fly with it. Just give it
it wouldn't be fun unless it was
difficult. Nothing like giving a live demo. Okay, let's try this again. Okay, I think it's happy now. I don't know what you're looking at right now. Are you looking at the camera or at my? So basically, well, all right. Let me switch to sharing my screen again, or am I? I can't remember what I'm doing.
That's fine. Yeah, just
share my screen. So I can show you the actual.
There we go. Yep. Got it.
Now I've got it set up to not only fire events up to platform, but also to print the console. So if I do this, if I get too close, it's going to tell me I was too close. And now and you can't actually see, but it just sent a message up to platform.
Yeah,
so,
I'm going to demo that in a second, by the way. So keep going.
So every time I get my hand too close, it's going to say you're too close. Now there's another mode to this. We can actually edit the script on the fly.
So while you're doing that, can you jump to the part of the script that had the interrupt logic?
Yeah, I'm actually going to change it right now. So I wrote the script so you can actually tell it if you want. I want to interrupt on ambient light level instead. So let's change this right now. So I'm going to do whatever. So now if I cover up the sensor, it's going to tell me it's too dark. See? And if I put it right up next to this light bulb, it hopefully will say too bright. See? So now I have, because you can interrupt on high or low conditions. Interrupting on low proximity was so noisy I turned it off, but it shows the idea of, and now it's just ambient, so it's fine. So we can look at this now. So down here, so down here we actually look at what you've configured. So obviously we set up the sensor. We turn on the infrared LED to maximum current. Tell it to sample at 250 samples a second on the proximity sensor and 2 samples a second on the ambient. We say if you set your if you want to interrupt on proximity, we set up some values. So we say turn on interrupts. We want to interrupt on the proximity. If it's lower than 1,000, which it will never report a value that low, it seems to floor out at about 2,000. I don't know what units of proximity it gives me. It may just be some kind of like infrared absorption. It may actually be amount of infrared light it sees bouncing back. 3,500 is about half an inch. So again, we don't have a real scale for this. And then I told it I have to see eight values above 3,500 or below 1,000 before it throws an interrupt. So you can actually kind of smooth out your signal. If you just see one reading that's high, and you're like, well, I actually want to know that it's been high for 8. So remember, it's sampling 250 times a second. So 8 is pretty quick, but at least it kind of smooths out your signal for you.
Nice.
And then obviously in ambient, we do something similar, except we have different values. 10 for low light, which is what when I put my finger over it, you saw it say it was only 3, and then 5,000 for too high. I believe these might be in locks. I don't know. Again, I don't remember off the ambient either. I just read out the register that it tells me to read out right now. So, and then I say I have to see 2 of those, and then that's how we get both interrupts. And now down here, when we see an interrupt, so obviously hang on up here, we actually configure interrupt 0 on a falling edge. So we say we want to watch interrupt 0, and if we see a falling edge on interrupt 0, tell us. So every time you sleep or HE.wait, it will return the current time once the sleep is over, and if there were new events, and then what they were. And events are basically interrupts. So when you were sleeping, was there an interrupt? And down here we say, if there was events, and we say, all right, let's see what the device was configured to do. And we see if it was, we see the interrupt type, and we see the interrupt status. So the status would be, was a high threshold exceeded, or was a low threshold exceeded? Because remember, we have highs and lows. We're basically saying we want to be in the middle of this range. So then what we do is we figure out if we got a low threshold, and if it was light, then we say it was too dark, and if it was proximity, we'd say it was too far, because low would be too far away. And then similarly, if it's a high threshold, if it's a high threshold and it's light, then it's too bright, and if it's a high threshold and it's proximity, then it's too close. And that's how we figure out what kind of interrupt we're getting and do the appropriate thing. So you actually see here, this script will do a whole bunch of stuff. It will send proximity, and it will send light every sample interval. As an interval or interrupt, it will also send a Boolean event to tell whether you were too high or too low. So for too dark, it will be a false, and for too bright, it will be a true.
All right.
That's how that works.
So let's see if we can really test the limits of this demo. I am going to, can you just kick that script off again? I'm going to switch over to my terminal and see if we can
sure.
over here. Time. So what I'm going to do here.
You want to do ambient or proximity?
You choose.
Well, proximity or ambient is actually neat because you can do I can do both ranges without it being horribly noisy. So if I cover this up, I think we're still in ambient mode. Yep,
okay. All right. So I'm going to focus on my screen here for a second. Andrew's over there running that script. So what people see right now is called Helium Commander, which is our cloud command line interface. And so if you go to dev.helium.com, you can read a full guide on Commander. It's quite a slick tool for talking to the Helium cloud. We've got 2 CLIs. We've got the Helium Commander CLI, which is cloud and API based, and then we've got Helium Script CLI, which lets you run CLIs or scripts rather locally. So if I do I'm already in Commander here, but if I do a --help, we can get the full list of commands that people can get from it. So what I want to do, and I'm actually wired into the same org that Andrew's using, using an API key. So I can do a Helium. Can you read that, Andrew? Yeah.
Yeah.
All right, make it a little bigger. Helium sensor list. So we're looking for the VCNL, so this one here, and we want an ID. So we can take this ID and do, sorry, pardon my copy and paste capabilities here. So we do Helium sensor time series list and get the last 20 readings from this sensor. Ports are
there it is.
Yeah, so ports are how we identify the value. So you can give a name to a port. We've got some that are already kind of pre-built into the platform. We've got a doc coming out soon that talks about how we treat ports and data types, whether it's an integer or a float or a Boolean, and how that gets graphed in dashboard natively. So PR here is the proximity sensor. L is the light. L_int is that interrupt on the light that Andrew was just demonstrating. And then
so that was a too dark event because it's false.
Yeah, and so if we wanted to take a look at all of those, for example, we could say -- port and then go L_int, and we'll get the last 20 if there's 20 of those. The other fun thing we're going to try here is to take a look at Andrew doing stuff to the sensor in real time. So if we go like this, change it to live, and then I change the format here, CSV. So we can output in CSV, JSON, and maybe TSV. We can do this, and form R is not yet a thing. Let's try this again. All right, so what it's going to do is spit out ID, sensor, timestamp, port, and value. And so if Andrew would be so kind as to
hold it up to the light bulb to get a nice giant value here.
Yeah, and so there we are.
There you go.
God, that's so blurry. So what's happening is he's got that sensor that we just showed you, the VCNL 4020 or 4010 rather, at his place in Marin County, and he's triggering the light interrupt, and he's taking light readings and pressure or proximity readings rather. This is firing through Helium access point, which is somewhere in your house, I imagine.
Yeah, it's in the other room.
Yeah, so somewhere in his house, talking to the Helium cloud, and then we're sitting on this live via Helium Commander. That's pretty damn cool, if I do say so myself.
Yeah, so
yeah.
You can see that if you look at this, the proximity when I was holding it up to the light, the lux value was 9600, but the proximity was very low because I wasn't near anything per se. But I just put my finger over it for the second, the L_int false. You can see the proximity was 12,000 because my hand was like right on the sensor there. So you can see the lux was only 10, but the proximity was off the charts because my finger was like literally covering the sensor.
Nice. Okay, so one last thing because we're running out of time here. I'm going to switch my screen again here. So we have the ability to not only put this into something called Commander, which is API based, but also show the data to you in Dashboard, which is the hosted visualization layer that we have. And I'm trying to find it over here. All right. So again, the same data that we just showed you in Commander is, can you see that, Andrew? Yeah. Okay. We may have lost Andrew's audio.
I'm still here. I'm still here.
Yeah. So you can see. Are you looking at Dashboard over there?
I am.
I'm just going to filter here for the VCNL sensor. So as you can see, Andrew's been using this to do a lot of prototyping. So pretty much every port data that comes off of the sensor will be graphed if we can graph it here in Dashboard. Temperature and pressure are actually the default or the stock ports that ship with the dev board. So those are always going to be there. So light was what we were just doing, and then PR is also what we're just doing. So we can zoom in here and get a couple light readings. And if Dashboard knows how to graph it, it'll just put it on this X and Y axis here with timestamps. And yeah, so that is a quick demo of how it looks in Dashboard. And hopefully you can get a picture of how it works end to end from the script that generates the data all the way up through Dashboard. Dashboard is a very basic visualization layer. Most people are taking that API data and wrapping it into their own application. So yeah, we did it. Anything else on your mind?
No, I think that's, given that we're at 10:30, I think we've covered everything we wanted to cover.
Nice. Okay, so that was two sensors. That's the 9-axis accelerometer and the VCNL 4010, which is ambient light and proximity. We're going to have a guide up on dev.helium.com later today, actually, which shows you how to build that full sensor so you can do exactly what Andrew and I just walked through. Before I forget, store.helium.com with DevKit20 to get yourself 20% off of dev kits. 2 other announcements. We've got a training happening in Chicago on March 9th. I'm going to be leading that with Reed Draper and a couple other members of our team. And I'll put the registration details for that in the notes, and we'll tweet that out. And then we're also going to do a training in Chicago, New York City, rather, on March 15th, which is a Wednesday. We've got only a small number of seats for that one, I think 10. And that'll be a day after we do a meetup in New York City at Hardwired NYC. So with that, I will let you get back to your script tinkering, Andrew, but thank you for your time.
Thank you.
Yeah, and to everybody, we'll see you hopefully next week. Go buy DevKit. Thanks.